We're now going to be looking at a section called Connected Rates of Change. Now, to introduce this, what we're going to be looking at is, in this example, a bath that is being filled up, a tap has been turned on, and the water is streaming into the bath at a constant rate. Okay, so that's important, that it's at a constant rate. So the rate at which the volume of the water, or the volume of the water that's covered in the bath, is changing with respect to time, could be written as dV by dt. So this means the rate at which the volume is changing with respect to time. So as time goes along, this is the rate at which the volume is increasing in this case. Now you could also look at the depth of the water as the water pours into the bath. So you could also look at the rate at which the depth, so let's say the height of the water with respect to time. So how the height of the water is changing with respect to time, the rate at which it's changing. So we would have a dV by dt, we would have a dH by dt. So is there a way that we would be able to connect these two things? Where is the connection? And the connection lies in the chain rule. So we would be able to write dV by dt as the product of two rates of change, of two derivatives. So we could have dV by dH times dH by dt. So the dH's, in effect, cancel each other out, leaving you with the dV by dt. So here is the rate at which the volume is changing with respect to time. This is the rate at which the height of the water is changing with respect to time. And this would be the rate at which the volume is changing with respect to the height of the water. So as the height of the water changes, how is the volume of the water changing? And so you can see that there are a distinct three bits of information that we need to consider. And that is what is going to be incorporated into the problems that we look at. Okay? So we are going to be looking for three bits of information, one of which we want to calculate, one of which we will know, and one of which we may have to work out. Okay? So we're going to go through a few problems to show you how this works.